Hello and welcome. My name is Brian McKay, and I'm from the Technical Marketing Group at MathWorks. Today we will talk about Raspberry Pi programming using Simulink. I'll show all the pieces of software and hardware you need and how to get it working. Our agenda: I'll give a brief introduction to the Raspberry Pi. I'll talk about the software setup, including the installation of the Simulink support package for Raspberry Pi. I'll talk about the hardware setup and show how to test that the hardware is connected and working. We'll build and run a model, and I'll use an image inversion example. Finally, I have two other demos: an object detection example, which detects a green object and paints a dot on it, as well as a barcode reader, which looks at a barcode and outputs the numerical digits. And finally, we'll have some time for wrap-up and question and answers. First of all, let's have a quick look at a working system. So there's my image inversion example. You can see my Raspberry Pi. You can even see the lights flashing. I've got some other props, including a barcode and a green tennis ball, and you can see some of the various cables. I'll go into detail on all these parts later. So the introduction to the Raspberry Pi. So what is it? It is a credit card size, low-cost, single-board computer with audio and video input-output, and it was really designed for teaching. It was created by the Raspberry Pi Foundation. You can get more information about them at raspberrypi.org. The specs: it's got a Broadcom system on a chip, which includes an ARM11 processor running at 700 MHz and 512 megabytes of RAM. It has a peripheral connectivity for stereo audio and digital video up to 1080p, and supports USB and Ethernet, and it's fairly small, 86 millimeters by 56 by 21, and weighs about 45 grams. The overall real-world performance is something like a 300 megahertz Pentium 2. So, if you're not aware, there are two models of Raspberry Pi, Model A and Model B, and so what's the difference? The Model A has 256 megabytes of RAM, one USB port, and no Ethernet ports, while the Model B has 512 megabytes of RAM, two USB ports, and an Ethernet port. We should note that the MathWorks only supports Raspberry Pi Model B, as we require the Ethernet port to download code. How much does it cost? It's approximately $35 in the US for the Raspberry Pi Model B. Cases, peripherals, and starter bundles are available from a variety of vendors. And where can you get one? A couple places to start is Premier Farnell or Element 14 and RS Components, and there are many other small internet vendors that offer Raspberry Pi. You can Google one probably right now. And for more information about the Raspberry Pi, check out their FAQ at raspberrypi.org. So the software setup. Let's talk about what we need. We need three things. First of all, we need some MathWorks software. That's MATLAB and Simulink, released 2013A or newer. And that can include the student version. However, we should note that the Raspberry Pi support is available on 32-bit and 64-bit Microsoft Windows only. We will need a compiler for the MathWorks software. In order to find one, there's a helpful link there that lists all the supported and compatible compilers for MathWorks products. For my 64-bit Windows 7 installation, I'm using a Microsoft Windows SDK 7.1, which is available at no charge. And the third thing we need is a Simulink support package for Raspberry Pi hardware. What is that? It's a set of Simulink blocks that allow you to generate programs that run natively on the Raspberry Pi. It's downloadable and it's free. Where do you get it? You get from the MATLAB tool strip. You can click Add-ons and get hardware support packages, or you can also type at the command line Target Installer. The support package installer actually leads you through an installation process and installs all the software you need to run on a Raspberry Pi from Simulink. So let's go get it. Okay, the first thing I need to do is check my MathWorks software. Remember I said you needed release 2013A or newer. I am running release 2013B, so I'm good to go. The second thing we need to check is the compiler. One way I can do that is to type this command mx-setup. This goes and looks for installed compilers. So yeah, let's go take a look. It says that I have Microsoft SDK 7.1 installed, and so that's the one I'm going to select. And yes, that's the one I want. You may need to install the compiler, but this is how you set it up. And finally, we need to get to the support package installer. There's two ways to do that. The easiest way is click Add-ons and get hardware support packages. This starts the support package installer. I almost always install from internet because this gives me the latest greatest support packages. Also note, if you ever need to uninstall a support package, that checkbox is available here. So here I'll click Next. On the left side, you'll see all the pieces of hardware that have support packages, supported by the MathWorks and a variety of products. In my case, I'm interested in Raspberry Pi right here. You can see that it gives me an action, which is to install. It could be reinstall, it could be update. It tells me what the installed version is, the latest version, the required base product, which is Simulink, and the supported host platforms. I have Win64. So here I'll just click Next. Next, it asks me to log into my MathWorks account. So here I'll click Login, and I can type in my password. Don't worry if you don't have an account. You can click the Create an Account link and create one right away. Click Login. There's a software agreement. I click I accept, and Next. Now this lists all the third-party softwares that gets installed to make the Raspberry Pi work. So there are 3 pieces, and you can see the link for each of them as well as the license agreement. The support package installer actually goes out and grabs all of these pieces and installs it correctly for you, so you don't have to do it manually. That makes the installation go much, much faster. So right now I'll click Next and then Install. Now the support package installer is going to download all the pieces of software, install them all, and register them. My installation is really fast because the support package installer is smart enough to check to see that I actually have already downloaded the most current versions of these files, so it doesn't bother to download them if I already have the most up-to-date version. And even though the support package installation portion is complete, we still have some more setup to do. And here we click Continue to move forward with the setup tasks. Okay, first we check to make sure that we're doing the setup for the correct hardware platform. For us it's Raspberry Pi, this is correct, and we click Next. The Raspberry Pi requires firmware. This allows it to boot and operate. The support package installer provides the tools to basically go to the internet and download a Raspy and Wheezy Linux firmware image, and provides tools to write it to an SD or SD microcard on your host PC. So to move forward, we'll click Download. We need to configure the network. You can either do a local area home network, a direct connection to the host computer, or manually enter network settings. I typically pick manual, and actually I set up my own address. I almost always use 169.254.0.31. Why .31? Well, 3.1 equals pi. You can also set the host name. I'll use the default. Now it asks us to insert the microSD or SD card into a drive into our host PC. Mine is under drive D, so I can go ahead and click Next. If you need to, refresh to find the correct drive letter. When we click right here, it's going to erase all of the information on the SD or microSD card, and it takes a bit of time to do the download and writing process. I'm going to skip ahead to the test process. Okay, we've completed the firmware step, and now we need to connect up the hardware. First thing we do is we grab the microSD or SD card from the host PC and put it in a Raspberry Pi. We connect an Ethernet cable to the Raspberry Pi and to our host PC. I do this through a USB to Ethernet adapter, and then you connect a micro USB power supply and connect that up to a USB port on your host PC or a hub. Once you do all that, give the Raspberry Pi a minute or so to boot up, and we click Next. Here we can confirm the board configuration. You can see the host name, and one really important note is if you ever forget the host name, the Raspberry Pi hardware will speak its IP address through the analog audio connector when it boots. So just plug in a set of headphones, boot the Raspberry Pi, and you'll hear the IP address that is assigned. The other thing we can do here is test the connection. So this tests the connection from our host PC to the Raspberry Pi. So I'll click that now. It says the connection is successful, so everything should be set up correctly. And we can click Next. Our setup is complete. If you want to see support package examples, you can click Finish, and they'll open up in a different window. With the Raspberry Pi support package, there's examples. There's things like Getting Started, which will give models and examples on how to get started, as well as examples, such as image inversion, which I'll run a little bit later. Okay, we're going to go back to the slides to recap. In summary, the support package installer installs all of the software elements you need to connect to and run on a Raspberry Pi, both the Simulink files as well as third-party software products. It does require a MathWorks account login, but don't worry if you don't have one. You can create one when you get to the screen. And it provides a utility to write the firmware onto an SD card. And you need to do this only on the first installation. Once you get the firmware written, you can move forward without doing it again. Okay, let's talk about the hardware setup. What hardware do we need? We need a Raspberry Pi Model B. We need a power cable. The Raspberry Pi has a micro USB connector. So I use a USB-A to micro USB-B cable for power. This lets me plug the USB cable into my host PC or a powered USB hub and provide power to my Raspberry Pi. We need an Ethernet cable to connect between the host PC and the Raspberry Pi so they can communicate with each other. We need an SD card. However, a micro SD card that sockets into an SD shell also works. Obviously, we need an open SD card port on the host computer. As we saw before, we needed that port to write the firmware onto the SD card or micro SD card. You can use a native port or a USB-based device. And we need an open Ethernet port on the host computer. A good option, especially if you have a laptop and you only have one Ethernet port that might be already used, is you can get a USB Ethernet dongle. This plugs into a USB port and gives you a second Ethernet port. We can get a case for our Raspberry Pi, which is really nice to have. And then for our examples, we need a USB webcam. You can see some of the parts in the screen capture there. The USB Ethernet dongle, my micro SD card reader, which has got a USB connection, and a micro SD card with an SD card shell. How do we hook it up? Well, we plug the USB Ethernet adapter into the host PC, and then plug in the Ethernet cable into that and the Raspberry Pi. We plug in our USB webcam into the Raspberry Pi. We insert the SD card, which in our case is a micro SD card, into the SD carrier, and we put that into the Raspberry Pi. Then we attach the USB power cable. I attach USB-A to my PC and the USB micro B to the power port on the Raspberry Pi, and we wait a minute for the Raspberry Pi to boot. So let's go test it. Okay, the first thing we should do is check to make sure our support package was installed correctly. We can do this by looking at the Simulink library, and here it is, the Simulink support package for Raspberry Pi hardware. We can also use the command line. Type in Raspberry Pi lib, and this opens the block set. You can see the blocks here. We have UDP send and receive, audio capture and playback, video capture and display, GPIO read and write. The GPIO pins are special to the Raspberry Pi and provide additional digital signal lines, as well as the LED and eSpeak text-to-speech. Remember those examples? If you lose track of where they are, you can always double-click on the blue block to get them back. Alright, the next thing we want to do is test our connection to the Raspberry Pi. I do that by using ping. Type in !ping with your IP address at the command line. This actually executes the DOS command, but from within MATLAB. If you see something like this, where you've sent 4 packets and received 4 packets and 0 were lost, that means you're connected correctly to the Raspberry Pi. So don't forget the ping command. It's really, really helpful. Finally, let's open the model that we want to run. We want to open the Raspberry Pi inversion model, and there it is. It's actually pretty simple. It's just got a video capture block, which has a device name and image size, sample time. It's got a really, really simple algorithm and a display. So, how do we run it? Well, the first thing before we run is we check Tools, Run on Target Hardware, Options, just to make sure everything's configured correctly. We have the right target hardware, and we have the right host name, so we should be good to go. There are 2 ways to run the model. The first is the Deploy to Hardware button. Use this mode if you do not wish to interact with the application running on your Raspberry Pi from the host computer. However, I want to see the video display, and so therefore I do want to interact with the Raspberry Pi from my host computer. To do that, you use External mode. So you use this selection box to external mode, and in order to run in external mode, you click the Run button. This goes, it takes the drivers, gets the code, and downloads it starts it running on the Raspberry Pi. So in a couple seconds here, we're going to see some windows open up, including a display window, which will show us the inverted image. We're almost there, and there's my display window. You can see this running. I can even move the objects around, tilt up my Raspberry Pi. And this algorithm is running natively on the Raspberry Pi. It's not running on my host PC. My host PC only is showing this display. Alright, so how do we stop it? We go back to our model and click the Stop button. What about this DOS window? Well, this DOS window gives you some idea of what's going on with the model, but if you see simulation finished, you can just go ahead and close it. And let's go back to the slides for a review. Okay, as a summary for our testing, we checked for the support package installation. The Simulink support package for Raspberry Pi hardware should be in your Simulink library. You can also type at the MATLAB command line, Raspberry Pi lib. You want to test your connection from your host PC to your Raspberry Pi. Remember that ping command. Use exclamation point ping with your IP address and you should see the result with 4 packets sent, 4 received, and 0 lost. So that gives you an idea that you are connected correctly. We opened up the Raspberry Pi image inversion model by typing Raspberry Pi _inversion at the command line. And then we wanted to double check. So we clicked Tools, Run on Target Hardware, and Options. Make sure that the target hardware is equal to Raspberry Pi and check the IP address. And then to get it to run, we used actually the external simulation mode and the Run button. The external mode allows you to tune parameters and monitor signals, like the display, in the model while the application is running in the hardware. However, you can use the Deploy to Hardware button if you want to run on the hardware with no interaction from the host. And we saw that our model was now running on the Raspberry Pi. Okay, now we're going to go through 2 more examples. The first is an object detection example where we will locate and mark the center of a green object. And the second example is a barcode scanner where I can scan a barcode and output the numerical digits. So to do this, let's go back to MATLAB. I need to open my first example, but before I get started, let's just make sure I'm still connected correctly. So I'll ping, make sure. Yeah, I'm fine because there you can see I've sent the packets, received them, and lost 0. So I'll start with the object detection, and here's my model. It's actually fairly simple. I have a video capture block. In the block you can see I have a device, an image size, type of format, and a sample time, and I have a display. And the most interesting thing about this is that the actual algorithm is a MATLAB function. So it's MATLAB code imported into Simulink. The way this function works is I just get the RGB components and a threshold. I calculate something of what green is. If my green is greater than the threshold, then it qualifies, and I find the center of that green thing, whatever it is. I put a red dot on it, and I output. So in order to run this, remember, first we go to Tools, Run on Target Hardware, and Options. We're just going to make sure that we're hooked up to the right hardware. Yes, we're on Raspberry Pi. That's my IP address, so we're okay. And in order to run, I'm going to run in external mode so I can view the display on my screen, and I click Run. This prepares the model, generates code, downloads it, and starts the model running. Now we're in the download phase. You should see some windows pop up. And connecting to the Raspberry Pi, and there we are, we're running. So you can see that dot on my green tennis ball. I can reach back here and I can move it around and it'll track my tennis ball. One other interesting thing I can do is I can put a second green object in. I've got a glass here, and you can see that the dot moves because it's trying to find the center of all the green stuff. So as I move my glass in different spots, you can see that the center is moving around. And as I move it off, it'll go back to the tennis ball. So that's a really simple algorithm. Makes a really nice demo. Okay. So being done with that demo, I'm going to click Stop. And we'll take a look at the next demo. Let me close down some windows. And let's look at the barcode demo. Go ahead and open my model. Here's my model. It's very similar. It's got a video capture and video display. But in this case, it's got a lot more processing under the hood. Various types of barcode recognition and validation. There's different types of code book generators, that sort of thing. So a lot more going on under the hood here. But in order to run it, we do the same thing. Tools, run target hardware options, make sure that it's configured correctly. Yes, Raspberry Pi, yes, my IP address, that looks good. In order to run, pick external mode and click the run button. Again, this will build the model, generate the code, compile everything, download it, and begin it. Shortly, again, we'll see a couple of windows, and we'll be able to see how this barcode works. Starting up now, connecting, and here we go. So I've got a barcode there. Let's see if I can get this zoomed in and reading. Okay, I've kind of adjusted it so it reads correctly. You can see that prefix is a 9. And it's basically scanning that barcode, translating the bar graph, and outputting in numeric digits. So that's pretty clever. The reason you have to move around the webcam or enlarge the barcode is because webcams that you typically buy online have a fixed focal length or do not autofocus. Their typical focal length is around 40 centimeters. So you need to get it set up correctly so it can read the code. Alright, we can go ahead and close this model down. Click stop, and we're going to go back to wrap up. Okay, so we saw a couple examples, object detection and the barcode scanner. Let's wrap up. So Simulink supports a wide variety of hardware, both natively in Simulink through the support package installer and through third parties. If you want to see what all that is, you go to our website, mathworks.com, hardware-support. Here you can see everything supported by Simulink. A couple things to note. If you look at any one of these, it has a description of what it is, some getting started resources, and the required hardware and software you need. The other thing is if it has this green icon, that means it's available through the support package installer, which we used to install Raspberry Pi. And finally, there's lots of ways to sort and look at all the hardware support from across MathWorks on the faceted search on the left side. Specifically for Simulink, we have other supported target hardware. It includes the Raspberry Pi Model B, as you see, but also the Arduino platforms such as the Uno and Mega 2560, the Lego Mindstorms NXT, BeagleBoard and PandaBoard, and Gumstick Sovero hardware. And just a reminder that all of these features are available in student version. For additional resources, again, check out our website, mathworks.com/academia, or for more information on the student version, mathworks.com student version.